Today, we will be building an LED flashlight as you see here. My LED flashlight is powered on by two AA batteries. And when I turn the power on, my flashlight turns on. And I can also adjust the brightness of my flashlight by this potentiometer here. So as I turn my potentiometer, I can dim my light. And if I turn my potentiometer to a lower resistance, my LEDs get brighter. And here are the materials that you generally want in this project. You'll need some soldered flux paste, you'll need some solder wire, some LEDs. For your LEDs, make sure that they don't require too much voltage, otherwise the brightness of your LEDs will decrease. Generally, they can be any color. What you want to make sure is that your LEDs don't require too much voltage. As for our batteries here, we're going to use two AA batteries. If you combine them in series, we get a voltage of 3 to 3.2 volts, which is pretty much exactly what you see here. Just check your LED voltage before you use your LEDs. I have a switch here that turns my LEDs on and off. I have my potentiometer, which serves to adjust the brightness of my LEDs. And I have a 10 ohm resistor that protects my LEDs from an overcurrent. And here is an orange LED. If I put too much voltage on it, the LED will burn out. And as you can see here, my LED is burning out. And that is what my 10 ohm resistor is for. I have a battery case. This is completely optional. If you have something else that you can stack your batteries in series, like in this configuration, go for it. And for this battery case, this one already has a switch on it to turn it off and on. I'm just showing this switch here just as a visual representation of what you'll need. You'll be needing a soldering iron, you'll be needing a PCB board, and finally, you'll be needing a soldering wick. So before we start designing our LED flashlight, one thing that you need to know is that if you put your LEDs in series, the amount of voltage that you'll need adds up. But if you connect your LEDs in parallel, the amount of current that you'll need adds up. And in this scenario, because each LED that I have here uses 3 to 3.2 volts, and my two AA batteries is also 3 to 3.2 volts, I would want the total current draw to add up and not the voltage. So I'm going to make sure to put my LEDs in a parallel configuration. And if you have a higher current draw, that means the batteries that supply the power to the LEDs will be used up more quickly. But I would take that over than having more batteries that I would have to stack up in series. And you can put your LEDs in a parallel configuration by making sure that only the positive leads of your LEDs are connected together and only your negative leads of your LEDs are connected together. And for an LED, the longer lead length would be your positive side and the shorter lead length would be your negative side. Another way to tell is if your LED has a flat side. And here I have a flat side here, and whatever side is your flat side here is going to be your negative side. And the third way to tell is the amount of metal that you see inside your LED. So for your negative side, there's going to be a larger metal piece inside of your LED. And for your positive side, it's going to have a smaller metal piece inside of your LED. So moving on with our design, let's say this is our red wire coming in, and let's say this is our black wire coming in. So to label this as red and black. So at this point here, first we'll connect our 10 ohm resistor. This is the symbol for a resistor, and I'll label this as 10 ohms. After it goes through a 10 ohm resistor, it would go through a potentiometer. A potentiometer pretty much adjusts the brightness of your LEDs by adding or decreasing the resistance to them. And a potentiometer would look something like this. And here you can see there's three different pins. Let's call this pin 1, this pin 2, and this pin 3. Here would connect to pin 1. Here, where this arrow is, would connect to pin 2. And finally here would connect to pin 3. Pin 2 is where we'll connect all of our LEDs in parallel. And pin 3 would just be connected to ground. So as I'll connect to ground here. Now, if we want to connect our LEDs in a parallel configuration, we want to make sure that all of the positive leads of the LED gets connected to the red wire side, and all the negative leads gets connected to the black wire side. And for my PCB here, I want to make a 5x4 arrangement. And this would be the symbol for an LED, as I'll draw here, where this side is our positive side and this side is our negative side. And to put it in a 5x4 configuration, here we would connect all of the negative leads together and all of the positive leads together. So to do that in our 5x4 LED diagram, so the first step I have done, connected all my negative leads together, as you can see here, and they all connect to ground, or the black wire. And now to do the same thing for our positive side, I've connected all of my positive leads, as you can see here, and that would connect to pin 2 of my potentiometer. So now that we have the design in mind, I'm gonna go ahead and fast forward myself, making the LED flashlight. Let's go ahead and compare the diagram to the PCB circuit that's been made. So as you can see here, that's our red wire going to our 10 ohm resistor. This is our red wire here. This is our 10 ohm resistor. Our 10 ohm resistor is then connected to our potentiometer, which is right here. Specifically, it's connected to pin 1, which here is pin 1. Pin 2 is connected to my array of LEDs, which is right here. And this is my array of LEDs. And my third pin is connected to the black wire, which is right here. my third pin connected to my black wire. For my array of LEDs, my positive leads, I'll connect to the second pin of my potentiometer, which you can see here. And if I flip this over for this side here, you can see that the positive side is the smallest metal piece in the LED. And this pattern would continue for each row. And for my negative lead, which is the bigger piece inside of my LED, runs through this line here first, which if I flip this over, this line connects to ground. If I trace my finger, and this is my black wire going to ground right here. This part here is connected to my black wire, as you can see right here. And yeah, that's the whole diagram to circuit building process right here. Now, I will say that I should have picked LEDs that had a lower voltage range, say like from 2.5 to 3 volts instead of 3 volts to 3.2 volts. But I think for the purpose of this project, this LED flashlight at least works as a great night light.